Hello everyone, my name is DJ from ECA section and my roll number is 2295180410 and my this is my concept video physics and my topic is about relation between group velocity and phase velocity. A wave packet describes a particle. First, a wave packet is a group of waves with slightly different wavelengths interfering with one another in a way that the amplitude of the group is non-zero only in the neighborhood of the particle. A wave packet is localized, a good representation of particles. The velocities of the individual waves, wave packet, phase velocity, and group velocity. The phase velocity, the velocity of the individual waves which superpose to produce the wave packet representing the particle are different. The wave packet as a whole has a different velocity from the waves that compress it. Phase velocity. The rate at which the phase of the wave propagates in space is called phase velocity. Group velocity. The rate at which the envelope of the wave packet propagates is called group velocity. Phase velocity means phase velocity is the rate at which the phase of the wave propagates in space. This is the velocity at which the phase of any one frequency component of the wave will propagate. You could pick one particular phase of the wave and it would appear to travel at the phase velocity. The phase velocity is given in terms of the wave's angular frequency omega and wave vector k by wave velocity. Phase velocity is equal to omega divided by wave vector k. Next, group velocity. Group velocity of a wave is the velocity with which the variations in the shape of the wave amplitude known as the modulation or envelope of the wave propagate through space. The group velocity is defined by the equation group velocity Vg is equal to dou omega by dou k, where Vg is the group velocity, omega is the angular frequency, k is the wave number. The function omega of k, which gives omega as a function of k, is known as the dispersion relation. Next, velocity of de Broglie waves phase velocity. Moving material particle de Broglie said a wave is associated with which travel with same velocity as that of the wave. Let de Broglie wave velocity is W. So Vp or capital W is equal to Vg. Next, phase velocity continued. Hv is equal to mc square. V is equal to mc square by h. Therefore, W is equal to mc square by h into h by mv. W is equal to c square by v. So, particle velocity must be less than the velocity of light. W, capital W greater than c. We can say that de Broglie waves must travel faster than the velocity of light. Next, group velocity is equal to particle velocity. Equational represent a wave of angular velocity W and wave number k, which are superimposed upon it a wave. The process is called modulation of angular velocity and wave number dk by 2. Phase velocity is equal to wave velocity of carrier. Group velocity is equal to wave velocity of envelope. For more than two wave contributions, Vg is equal to dg by dk. The group velocity is the velocity of pulse of light, that is, of its irradiance. While we derive the group velocity using two frequencies, think of it as occurring at a given frequency. The center frequency of pulsed wave, it's the velocity of the pulse. When Vg is equals to Vp, the pulse propagates at the same velocity as the carrier wave, as the phase fronts. The wave occurs rarely, however, when the group and phase velocities are different. More generally, Vg does not equals to Vp, phase velocity, group velocity not equals to phase velocity. And the carrier wave propagates at the phase velocity and the pulse propagates at the group velocity, usually slower. The carrier wave is blue one and the envelope in radians is green one. Now we must multiply together these two quantities. The group velocity is the speed of the wave packet. The phase velocity is the speed of the individual waves. Phase velocity is equal to group velocity. The entire waveform, the component waves and their envelope moves as one non-dispersive wave when phase velocity is equal to group velocity. Next, phase velocity is equal to minus group velocity, phase velocity greater than group velocity, phase velocity less than group velocity, phase group velocity is equal to 0 and also phase velocity is equal to 0. Phase velocity is equal to group velocity. The entire waveform, the component waves and their envelope moves as one non-dispersive wave. This phase velocity is equal to minus group velocity. The envelope moves in opposite direction of the component waves. Phase velocity greater than group velocity. The component move from more quickly than the envelope. Phase velocity less than group velocity. The component moves slowly than the envelope. When phase group velocity is equal to 0, the envelope is stationary while the component waves move through it. When phase velocity is equal to 0, only the envelope moves over stationary component waves. Next, relation between the group velocity and the phase velocity. Here, Vp is phase velocity is k is wave vector Vg into d by dk. Vg into is equal to d of Vp into k by dk. Vg into Vp is equal to k dVp by dk. And this in this equation gives the relation between the phase velocity and the group velocity. And finally, the conclusion: waves can be in a group, and such groups are called wave packets. So the velocity with which have a packet travels is called group velocity. The velocity with which the phase of velocity wave travels is called phase velocity. The group velocity of waves, according to experts, is always directly proportional to the phase velocity of a wave. Group velocity and phase waves can be in a group. The group velocity and phase velocity relation can be mathematically written as Vg is equal to Vp plus k into dVp by dk, where Vg is the group velocity, Vp is the phase velocity, and k is the angular wave number. The group velocity is directly proportional to phase velocity. This means when group velocity increases proportionately, phase velocity will also increase. When phase velocity increases proportionately, group velocity will also increase. Thus, we see the direct dependence of group velocity on phase velocity and vice versa. Group velocity is the velocity with which a wave packet travels. Phase velocity is the velocity with, with which the phase of wave packet travels. The condition for dispersive waves is dVp by dk does not equals to 0. What is the condition to be satisfied for non-dispersive waves? The condition for non-dispersive waves is dVp by dk does not equals to 0. And the group velocity of a group of waves according to experts is always directly proportional to the phase velocity of a wave. As a result, the wave's group velocity and phase velocity have a direct link with one another. The group velocity and the phase velocity might be considered mutually exclusive. The relation between group velocity and phase velocity is proportionate, and the phase velocity of a wave is given by Vp is equals to omega by k, where omega is angular frequency and k is wave vector. Next, omega is equals to k into Vp. Vp means phase velocity, k means wave vector. Thank you.